Another draft physics video presentation. Alright, so comments. And you want to be a long comment, who knows how far we'll get through it. Going about the elemental theory, maybe I'll just explain why I think there needs to be a better theory. And how confident maybe in certain elements of the theory, something like that. But first, a stupid comment, of course. Are you allowed to call Mars a ginger planet? Oh, fascinating question. I don't want to offend red-haired people. I guess you sort of already did. Is that why Mars is the god of war? I don't know. It's too interesting. Oh, wait a minute. No, not interesting at all. Ugh. Pathetic jokes are, jokes are bad, but pathetic ones are really, So, I don't know. This is some kind of commenting on Discord, but I don't, whatever. I don't know. How well do I get it? Question mark. I'll put it in the Discord after this reality check. I don't know what that means either. Electron equals perfect reflection. Well, so does proton. So again, the idea, I would argue, the first thing to notice in physics after you go through all this stuff and look around is the charge thing. The charge thing is the magnet. It's, it's screaming at you. This is really strange stuff, blah, blah, blah. You got to explain this, this idea that there's, a positive end and a negative end, a north and a south, and they fundamentally do the inverse thing. So protons and electrons look at this thing completely opposite. They see an opposite thing. So it's sitting there being exactly the opposite thing. Whatever the opposite thing, like if they, one of them sees a hammer and the other one sees a goldfish. I mean, don't know how to do opposites, but and it's just, that's physics, right? I mean, we know that gravity is just the one kind of thing. Okay, it's doing this attraction thing, but it's not very sophisticated. The magnet's doing something, that's revealing. Charge is revealing. And if you go through the whole charge thing, you find out that charge is really just, that's what makes a magnet. So it's the idea that electrons and protons are fundamentally different that's making the magnet. You take a, positive charge and a negative charge, and if you could theoretically smash them right into each other, it would behave just like a magnet. Okay, in theory, it's no different. So how do you create this opposite thing? And that's all. That was the question. To me, that is the question in physics. Is you have to explain charge. If you don't explain charge, you haven't explained anything. And just saying it magically does something, screw that. I mean, it's this idea of a non-physical, But then you run into the problem of demanding a physical. And then you say, well, why does, whatever elemental thing you come up with, you can say, why does the elemental thing do what it does? But I guess what I'm saying is I think there is an end to those questions. And you just say, because. And if it's a simple enough function, because it's good enough. Okay, why does water flow downhill or something? You can ask a question and, the answer can be kind of simple. Well, gravity. And gravity is sort of a simple function, right? So it's got this obvious function anyway, up and down. All right, so in thinking about or contemplating this oppositeness, the only way I could come up with a way, if you can do it, fine, I'd like to hear it, of a single element being able to be opposite. That is, somehow this thing radiates something that this thing sees different than if there was a blue thing here, that same thing would look different. And that's the part that's kind of impossible, coming up with a single thing. Well, if it's a single thing, how can the two things see the single thing differently? Just doesn't seem possible that you could do that. So you really need two different things. And then you can understand that all the magnet's doing is filtering something. So all you have is the two reactions I've pointed out where, I'm reacting to the electron equals perfect reflection. Well, the electron equals perfect reflection in the sense that if an electron force hits an electron, it reflects. And if a proton force hits a proton, it reflects. Chalk is flaming on me there. And that's what I mean by perfect reflection. That is, essentially an exchange takes place. The object, loses something going that way, and it gains something going this way, and so it has some momentum this way. That's what happens after the action. The action creates action this way, and it creates a reaction of this going the opposite way. And the same would be true for the electron. Now the tricky one is the opposite force. So I haven't gotten this one entirely nailed down yet, but the opposite force hits the electron. The proton force hits an electron, or the electron force hits a proton, and instead of doing this momentum thing this way, it bisects the force, and the force leaves this way, and the momentum goes this way, or some variant of that. So the point is the motor force sort of indicates it can also go in and out of the blackboard. So it has a choice of which dimension the force is affected. So something goes in this way, and we have action perpendicular to the way it came in. And so the physics sort of matches that. So the idea of even, I don't want to use, so see, it's a little tricky using reflections off a surface, but I mean, they sort of give you this indication that you can change direction for free, that you can make something go a new direction, and it didn't cost you anything. But the truth is that there was an interaction on the surface, and that there actually was a reflection back this way too, but you're never going to see that one. And that this is it has been interpreted by the surface to produce this action, or transmission, or all the different kinds of effects you can have. So anyway, but that's a more complex system, and so you have to try to keep it in the simplest realm, and then come up with explanations for why they would have these specific rules. And so then you get into these arguments about whether these things can have, once they have this motion, is this motion permanent, or is this motion have a limit to it? And the idea is once it's moving, then it's moving into more of this force, and you have this whole subject of drag, and so it gets complicated. But I'm saying the basic principle works, and all you're looking for is the catches. And so the catch to drag, I would argue, is that this action, when you hit the opposite force into something, doesn't create motion, doesn't conserve direction. So there's no change in direction in the direction it was moving. So that fact that you can do that means that you can arrange these in such a way where you're bouncing energy between one thing that moves and things that don't move, theoretically. So the electrons could be reflecting their energy between a proton, and if the proton isn't pushed this way, but in fact doesn't move because of that force, and the electrons are moving this way, then they will drag the proton with them, and it will be a perpetual engine because it has energy trapped in a way that constantly changes the momentum direction. You could argue something like that. Anyway, so that's the theory. Now the reasoning is that we know gravity and magnetism and electricity and all this stuff moves the same speed. Therefore, it's sensible to say it all has to be caused by one thing, one kind of force, one kind of mechanism. A static dead ether doesn't work. The only thing that does work is that the universe has energy in it, and it's constantly moving. And as I pointed out, if you fill a box full of random energy moving in all kinds of directions at a constant speed, and then you put things in that box, that the things, if they reflect the force, will end up moving into each other. That the pressure is on this, the pressure holding the electron together is the same pressure holding you together, is the same, it's the universe's pressure, and all you can do is change how much pressure there is by changing how they reflect the force. So if you thought of them as mirrors, you're just changing how the mirrors are deflecting the light, so you have places that have shadow and places that have extra light. You can change the pressure. All right. Yes, could something pass through? It's irrelevant. It's sort of like the gravity argument. It doesn't matter how much of the force you're saying an object is absorbing, whether it's 50% or 90% or 80% or 10%. The point is it's enough percent to make a difference. Now, I would argue there's no reason to think anything passes through or does something else. So why bother with it? You can leave it an open question if you want, but I don't think it solves any problems. No, the electron is tiny. Well, the tininess of it is another subject. I'm arguing their atoms are tiny. Obviously, there's a lot of atoms in something, so they can't be very big. But relative to the proton, I might argue that the proton is small and heavy, and the electron is big and light, like the sun is different than the earth in terms of its density. So they could have different densities. And the fact is that electrons are hittable. To interact with something, photons have to hit electrons. They have to move them. And I don't think they're moving them by just going past them and magically communicating to them, hey, I moved past you, therefore you're going to get hit with some wave I'm creating or some, no, I don't think there's any magical tie that they have to each other. They actually do have to have this direct communication between the energy and the objects. The photons have to hit the electrons. So they can't be too small because then you couldn't hit them. So, relative to the size of other things, I think the electrons might be rather large. It's an unanswered question. You get into whole things about surfaces. You can sort of understand a surface, that's going to do a reflection. It has to be made of something. And if the electrons we understand are on the outside of the atoms, you can understand the electrons are, occupying the surface, but they can't be too close to each other. There's all kinds of rules. So then you have to have a second, the bottom electrons have to be staggered. And you can create a pretty dense surface, but you're saying if atoms are, what they say, 99% empty space, you're still going to have a hard time actually hitting one of them. And reflections aren't coming from deep inside of something, because then the reflections couldn't get out, because they'd have to plow through a whole bunch of stuff and have a chance of hitting something going the wrong way. And so it seems to me that the electrons must be of sufficient size to make them hittable. No, the electron is tiny, easily missed by most of the photon's volume. See, I don't know if it's most. They say the best mirrors we have, you might get a photon to go 12 atoms deep. So, yeah, there's some likelihood you're going to miss, but how small is small here? So we're saying, is it 50% of the surface area of the atom is an electron, or is it 25% or 10%? I'd argue it can't be much less than 10%, or you couldn't get 12 deep, right? So at 10%, you could argue that 12 would be about, it takes up 1/10 of the area, of the circle. So if I made a circle and said that's the atom, somehow the electron has to be occupying about 10% of that circle, or there's no way you could only go 12 atoms deep. You could go much deeper. That would be my approximation. Most of the atoms are the thing with empty space and therefore different obstacles, opacancies. Yeah, well, just the more mass in the more space, right? So some molecules are big and airy, and that's why they float. Helium, has less mass per space it occupies, so it's buoyant and it floats out of the other atoms. And then some atoms are more dense, that is, they're smaller and have more matter in them and sink. So you can just look at it as measured by buoyancy alone, you could answer a lot of these questions. How big the atom must be. So when a piece of steel, I think you can float steel on Mercury, I think. well, you can float some kind of, certainly you could float aluminum on it with no problem. So I mean, obviously you know, the mercury atoms have to be more dense, you know, more bits per square inch than the aluminum atom. Alright. Atoms are a thing with empty space and therefore different opacancies. Speaking of electrons, so opacancy is different than strictly density, right? Opacancy has to do with the configuration of the atoms. That is, the atoms are somehow not arranged in this nice order where electrons can communicate easily with each other and send an impulse to the other side of the surface. So clearly, photons interact with substances that have crystals in them. That is, the atoms are arranged in very specific geometry that allows the crystal to vibrate on one side and then vibrate on the other side to communicate a vibration or a movement of the electrons. And so the electrons can, you know, move in sequence through, you know, the atoms without being deflected and diverged and scattered. So there has to be a crystal to stop the energy from scattering. Opaque things scatter the energy, you could argue, and transparent things don't scatter. Could something pass through? Question mark. No, okay, we already did this. Speaking of electrons, I have trouble reconciling the perfect reflection and the electron as a trap. Yeah, so this is, you know, just sort of, you know, you want to go a step deeper, blah, blah, blah. There's more than one trap. So the argument would be is that you have a trap between two electrons. And the sense is that if something's reflecting, it's going to keep reflecting back and forth and back and forth. And then the closer the two electrons get to each other, obviously, okay, by obvious physics, these reflections happen more often, and each impact is exactly the same amount of energy. So it's more impacts means more energy, in effect, because it's the hitting that is the event. And so it's just like you're increasing the number of punches, and each punch has exactly the same amount of punch, because the photon is perpetual. It doesn't get tired, it doesn't wear down, it doesn't do any of that stuff. And so that's a trap, right? You could argue that, okay, that's a trap. You could theoretically, even if I move the electrons further apart, that piece of energy can just be trapped there for centuries or millennia. You know, it could just keep going back and forth. It's trapped in there. Now, another place where this trapping can be happening is inside the electron itself. You could argue that what the electron is there's a dead surface, right? Could be a square. There's no rules here. You know, they could be just little squares in space. You know, but anyway, so you could imagine that if something was trapped inside, so it's hitting the exterior surface, and the exterior surface will be as big or small as the amount of pressure. So the external universe is pushing in, and the interior surface is pushing out by having a regular bounce rate. And so the bounce rate is of such a rate that it equalizes the pressure on the outside. And so you could argue that what's happening when this pressure hits, you know, is that this shape changes, and as the shape changes, its motion changes. So the shape itself will process through space, or however you want to look at it. But you could say, if I contract this side, you could sort of understand that this interaction now is happening more often. And if the initial energy that caused that interaction was in a direction, it would just keep going in that direction. So when I say exchange, what I'm saying is you're essentially hitting at just the right point to change that momentum. It's different than just changing the surface. Somehow this goes in, or some new piece of energy goes in and changes the initial momentum because it undoes this. So it's kind of like you could say the arrows hit each other at the same time on this surface, or you know, whatever the particular event is. But that event means that now you're changing its internal you're changing its first cause. Its first cause was that. And all you can do is go from forward to 0, forward to 0. You could understand I can make it bounce back and it'll be 0. It won't be backwards, it'll be 0. I'll undo the motion when I hit the back side of something. So I hit the front side, I make it move. I hit the back side, it goes to 0. I hit the front side again, it moves again. So you see that? You should be able to get that point. So what you're doing is changing the initial cause. So whatever the initial cause is this, right? And so if I can change that, if through some event this initial cause arrow goes from that to this, well then I'll have exactly the opposite effect. I'll have 0, that, 0, that, 0, that. So I would argue that the electrons and protons are pulsing through space. They jump through space. They don't smoothly glide through space. And yeah. Like I said, it's what, 70%? It's not an answer. I'm saying, oh, I'm certain that's exactly how the universe functions. I'm just saying that this mechanism does work. That's the only. I'm just saying it answers the question of how motion, how something's momentum is decided, and that the decision can be some sort of arbitrary event that changes its initial condition, switches its condition. All right, perfect reflection on a trap. The fact will permeate. Okay, that fact will permeate the entire post. Okay, the external universe. So this is quoting something. I don't know exactly what it is. Hits the electron at the same rate. So that's just saying that the assumption is, and it doesn't really matter. I mean, relatively speaking, it doesn't matter. I'm just saying for the sake of argument, we could say the initial universe has a bias in a direction. So the whole universe is moving in some direction, right? It has more arrows going right than left. But there's no reason to do that, because it won't change anything. Because all you're looking to do, everything that appears to be stationary, right? I'm stationary now, but we know I'm moving through space. So through empty space, I have a definite vector. Every second, that vector's changing, but I have a different vector every second. I am moving in a direction, and in the universe, in the space itself, in my opinion, right? So yes, and it's always relative to something else. So if it's like I said, if the Earth is doing this, then I'm going to be doing that when I'm standing on the Earth, and I can always add another vector, right? I can decide to walk across the room, so I can always add another vector. But I'm doing these vectors are all vectors I have when I'm standing on the Earth. So motion's always going to be somewhat relative, in that different things can have a shared vectors, and then they can add more or less vectors relative to each other. But they have a real position in space. In any one moment they're here, or they're here, and then they go over here. But at any one moment they are in places, and it takes time to get to those places, and to get to those places they have to have their momentum changed. The traps have to have energy go into them. They have to absorb it and now become motivated to move. They don't move for no reason. They move because they have to be pushed. So everything that moves is absorbing energy. You can't do it any other way. It has to be hit by the pressure that's moving it. Except the big objects. Like I said, because big objects get complicated. Because you can do this trick, where, you're bouncing the again, I can put 2 protons and an electron in an arrangement, and what I'll end up with is more energy, the proton energy in this case, bouncing, going perpendicular out of the electron, and it just keeps going back and forth in these directions. It's adding momentum to the electrons, in this direction, but technically that doesn't matter. And the proton will just get dragged along because it's attracted to the electron by pressure, by a pressure unevenness. And so you have a little engine. But the engine has to be made out of a configuration of the space in the first place, and all these interactions are consuming energy. So when you add this energy, you do subtract some other energy. The electron doesn't store it. It has a certain amount. It's always contains a certain amount of pressure on the inside, but which way that pressure is pointing is what you're exchanging. So when you put in this, you put in this, you're going to give back this, or you're going to give back that, or you're going to give back something. All right. Okay. When you focus the drawing on source, receiver, and the rays between, it's easy to forget the omnipresent bombardment from all remaining sides. It's really easy for it to get really complicated, and just because of the density of it. So yes, keeping account of it is difficult. So that's why some of this stuff needs to be simulated. So, see, I would argue that you could simulate this, making all kinds of membranes, right? So I was using the word membrane before, or that the electron has a wall of some kind. Well, what if I just took away the wall and I just said there's pattern? There's arrow here, arrow here, arrow here. Now, if I put that in the big universe, what's going to happen to it, right? I mean, you could argue that the universe is going to hit it with energy going this way, and it's going to hit it with energy going this way, and it's going to hit it with energy going this way, and energy going this way. Now, you could argue that this way and this way energy, right? I'll do this, no legs on those arrows from the universe's pressure. So you could sort of understand that pushing it this way and pushing it this way would end up equaling. So that would be irrelevant. But how consistent, how able to save this pattern would it be able to be? Right? Say this is now a reflection, so this one now goes this way. But it hits this one, so it goes back this way again. How durable would this pattern be if I had this pattern and then I put the pressure on? Would this pattern of 3 arrows be broken or stay the same over time? So all I'm saying is the electron could just be pattern. It could be a certain pattern, and it has such a density, like there's 100 of these things coming out this way and 100 going out this way. And you could say, because of its density, you could never kill the pattern. The pattern just always wins again. So it's sort of like the molten part of the earth, right? I mean, it's really hot in the center, but somehow that heat never gets to the surface, right? I mean, it's a practical matter. Yes, little volcanoes now and then, but I just mean outside of the volcanoes now and then, the heat it can't radiate out of the earth in the sense that it somehow just always kind of just gets back to being internalized. It just kind of doesn't get out of the center of the earth. It just, in any, to any great degree. So somehow the fact that it has a certain density and transition area means that the pattern in here never gets to the surface here. I guess that's sort of the argument. How durable is pattern? Can you make a pattern that's indestructible? That is, you can vary the external pressure to some extent and it'll survive the variations. All right. When you focus, okay, we did that part. Between, it's easy to forget. Okay, that and only that is what causes the balance jiggle in the first place. Well, it certainly causes the situation where you could never say anything was ever cold. So they talk about absolute zero, and they talk about how they've got an absolute zero and all this. There's no absolute zero. You just can't evade the pressure. The pressure is always there, and the pressure is, in a sense, a kind of heat. And you're not going to ever stop it. Nothing can ever be frozen entirely, completely, precisely. You could say a single ray is responsible for different phenomena than the converging bullet rain towards the electron. You could say the single ray is responsible for different phenomenon than the converging bullet rain towards the electron. Well, whatever that is. electrons have to deal with individual bullets, so the bullets don't rain on an electron. Technically, they're all individual raindrops. To avoid accidentally forgetting that I like to think of real space as an ocean of crisscrossing rays. Yeah, well, most of it isn't in any form you would call a ray, so because it doesn't have a consistent frequency, so it's only a tiny percentage of the energy in the universe that we can now and then order. Because there's some physical structure in matter. It creates a interaction that has a timed routine, and the routine is the same each time, and it produces the little blobs of exchange at the same interval. So a tiny percentage of the universe is doing that. And even when it's a photon, we know its polarization is rather eccentric. It's rather large. So it's not exactly a ray. I mean, this is a ray, yes, but it's not a ray like a really thin line. It's thousands of atoms out of alignment. So, yeah. So obviously when you get to gamma rays and really high frequency rays, then you can talk about having something that's really more like a ray. Okay, that convergence, let's see, to avoid accidentally forgetting that I like to think of space, crossing rays, not subconsciously ignore the converging force. Well, the fact that random, I mean, that's one of the key, one of the key things to understand is that, yes, I can just create a random field of stuff moving in all directions, and any object in the field is only going to interact with the stuff that's heading right for it. So only the arrows that are heading right for it will be interacting with it. So obviously its perspective will be that this is a very organized pressure, that somehow this chaos means I get hit with this perfectly symmetrical amount of energy. And yeah, so that's sort of a thing you always have to keep in mind, is that chaos creates a perfect, reverse light bulb. So when you're put in a field of chaos, somehow it turns into this perfect force, that radiates to you just like as if you were a light bulb radiating out. All right. The convergence, of course, comprised of the same single ray phenomenon, just with another source directions. Okay. Anyway, external pressure is the same as the internal pressure. Well, the argument would be as they reach equilibrium. So the electron is the size proportional to the pressure hitting it from the outside. So whatever size it is, it's that size because that's how much pressure is hitting it. And you could argue that the whole universe is functioning that way, and so that the size of stars and the size of galaxies is all dictated by the amount of gravity pressure. And that, in fact, if gravity is these arrows, that if you separate the mass, the matter, and if you release any of the energy in the matter, that you would essentially create less pressure in the real universe. Now, the inverse argument could be made that, say I have these matter bits in space, okay, if I make them bigger, right, then I make less empty space, and therefore the pressure has less space to travel through because I'm used up. A whole bunch of this empty space got used up. It can't travel through this empty space anymore. And this empty space is unavailable. So this pressure increases. The external pressure increases as this pressure, as these things expand in size. So you can argue there's always a yin-yang proportional relationship. The pressure is either on the inside, a little extra pressure, or there's extra pressure on the outside, kind of thing. So you could argue that the universe is in a constant state of expanding, getting stuff expanding in its size, like galaxies getting bigger, and then the pressure pushing them back together again. And that's all they do, is get big and then get small and then get big and then get small. All right. External pressure is the same as internal pressure. Okay, at 153, you referred to electrons as possibly patterns in space. Yes, I already covered that. So please don't shut down this claim, this chain of thought, in the first chance you get. I'm not implying that you wouldn't try to play along anyway, just saying I'm the one on the defensive in this. Okay, so you're wish to go somewhere I don't think you need to go, but okay, wherever. I mean, it's not. There's places you can make strong arguments, and then you have to make, it gets weaker and weaker when you try to just speculate about something you have so little information about. Could the electron in this case be likened to a hollow Swiss cheese asteroid? I don't think that's going to work, no. And the asteroid being blasted with an array of non-weakening, constantly ray-shaped, retaining jets of water from all directions. Well, whatever. So you're saying it has holes. Stuff can get into the holes, but it also has to get out through the holes, I suppose, right? The inside pressure being a byproduct of the outside pressure. I don't, like I said, it's either a container or not a container. You can't hold water and have holes in the container. You know what I mean? You can't equalize the pressure that way because it wouldn't accomplish anything, I don't think. Entering through the holes into the cheese asteroid and reflecting in there. So you're saying it's just, I think there's probably a simpler way of illustrating the point, but so we're saying that we have this membrane, but it's some sort of solid, and we just put holes in it. And so now the energy can either reflect off the places where there's no hole, or it can go into the hole and go inside the hole and create more pressure on the inside. And as it creates more pressure on the inside, somehow it knows, somehow that means more pressure will come out the hole. So eventually you'll lose something out the hole. So you're just doing the exchange in some, I think, more complicated way, right? I mean, you're really just saying that I'm going to exchange the direction. So something's going in this way and something will go out going this way. And you're just using this hollow cheese to do the randomizing. So clearly it's something like that's happening, but my pressure argument was more about the energy on the inside having to either expand the surface or escape. So if we said this was a rigid size, and then we provided a mechanism that allowed things to go in, okay, and the only way they can come out is through some other method. I mean, so yeah, I'm not saying what you're saying is impossible to construct it. I'm just saying that you're still stuck with how you create in and out. What allows something to get out and what allows something to get in. And they can't be the same mechanism, in my opinion. All right. The inside pressure being the byproduct of the outside pressure entering through the holes into the cheese asteroid. Okay, every jet that wasn't already reflected by the outside walls of the asteroid is now bouncing back and forth between the inside walls, inside pressure, until it reaches another hole through which the jet leaves. Right, so you could argue if you expanded the inside pressure, and that it did actually increase its size, you could say it made the holes bigger, right? But it would make them bigger for stuff coming in as well as stuff getting out. So in a sense, that doesn't work. I'm just saying it's, whatever system you use, you're going to, yes, there's a catch to it, and it's figuring out what the catch is. So, like I gave the example of the radometer, the little spinning triangles, and there's just this subtle difference, right? I mean, a strong vacuum, they're spinning. A stronger vacuum, they stop spinning. And it's because there's a little subtle mechanism with the atoms that remain where the energy reflects. And if it wasn't for those atoms, so the thing can't work unless those atoms are there to reflect the energy back onto the surface. So I mean, it's a little subtle trick. I'm just saying I'm saying for the purpose of the theory, I just don't know. I mean, that could, that's like doing the abiogenesis thing instead of focusing on the, more obvious evolution story. I mean, the abiogenesis has to be happening. There has to be a model for that. It's there. We just don't know it. Okay, there's a physical model. But, it's like, what are you going to devote your time to? Not saying it's not valid. I'm just saying I guess I'm more interested in getting the theory accepted than getting a precise answer to one question. All right. And the asteroid being, all right, we already did all that. Reflected of the now, back, okay, until it reaches another hole through which the jet leaves, making the entry hole and the exit hole into some kind of constant valves with constant pressure caused by constant speed of force. So yes, so again, you're conceding that you just have to say, well, they have to be some sort of, they can go in but they can't get out, some kind of, at least that's what I picture when you call electrons and protons traps. The ping pong paddles would also be the same walls. Yeah, well, I guess what I'm arguing is the principle that of the ping pong paddle and the principle of the bucket, the cart. The idea that the momentum, the initial momentum is the momentum. I mean, these are just really important fundamental ideas. So this fundamental idea that you can create two things that repel each other by merely having a force that gets trapped between them, and then you can create attraction by doing exactly the opposite, that is, making it so nothing can get between them. Everything goes this way, or, reflects that way, or, so the only momentum it can have is going this way, because there's not going to be anything hitting it this way except this stuff, but nothing between them here. So this becomes a very low pressure. So you can understand high pressure and low pressure. And likewise, you can understand this idea that whatever energy I first put into a system can end up giving you a system where, yes, you initiate go, and then when it bounces, it stops, and then when it bounces this way again, it goes again, and then it stops, and then it goes. And that idea creates a perpetual, it takes the perpetual motion of a force, and it makes it understandable that you can take the perpetual motion of the force is always in the one direction. That's its initial direction, is its direction. And it doesn't matter if you do this and this, this and this. You're always going to retain this forward motion. The going backward thing only undoes the initial thing, and the initial thing's going to happen again. You can't stop it, so it's going to go forward again. So even though you undid it by going back, you're going to redo it by going forward again, and then you're going to undo it and then redo it, and then undo it and redo it. All right, anyway. Our rule: measuring interactions of force bits and matter along a single line. I don't know what that is. Okay, measuring interactions of force bits and matter along a single line. Well, to have a rule like the R rule, you're really talking about how strong the force is. So it's an R rule when it's ping pong paddles. So I have the distance and I double the number of interactions. So it's just an R rule. It's completely half the distance twice, or half the force, the number of interactions. And then the R squared is the fact that if I take that rule, this R rule, and I spread it over a circumference, that yes, I'm going to end up the closer I get, the more angles I consume. So two things are far apart, the only angle I can hit is 90 degrees back and forth. But as I bring them closer together, I consume more angles of energy, and blah blah blah. All right. Magnetism loses, so the R cubed is about so yeah, I'm glad you just recited the rules. But the R cubed has to do with the dipole. So that just has to do with that if you combine the two forces, that from a distance, from close up I can see red and I can see blue. But if I put it far away, I just see purple. So the two mix in the sense that that's the R cubed rule. Is you're with distance you get more and more purple. And the closer you get, the more you can get the distinction between the red and the blue. So obviously these rules only, like the R cubed rule, doesn't work as soon as you get close enough to the magnet. So once you're close to the magnet, there's no R cubed rule anymore, because you're frankly going to move here or you're going to move here, to meet that difference. And we're not talking about affecting something that's not also polarized. So something has to have some charge component to be able to recognize a magnet. So if it's not charged, if it's a mixed dipole, the dipoles are turning in all directions, then this thing isn't going to be affected by any rule at all. So the only way it's affected by the rule, it has to be another magnet. And obviously if the two magnets are getting closer and closer, they're going to turn. And now it's not going to be the R cubed rule anymore. It's going to turn into like the R rule. So like Maxwell's equations, these things only fit in perfect worlds and in worlds where you don't put things too close together or too far apart. Alright, force bits hitting like light. Force bits are parts that make up light. So all there is the error, the little bits. So that's, that really should be understood by now. That 2 + 2 physics just means that I'm just saying there's a random field of force moving in all directions, okay, and it's of two types. It can be of this blue type or this white type, okay, so it can be electron force or proton force. And then there's two kinds of objects, electrons and protons primarily, and that a neutron is just a combination of those two very close to each other. And so there's just two kinds of force, two kinds of matter, okay, we just call them matter, and there's this two kinds of interaction. So you can interact by keeping your momentum all linear, in the same plane, or you can interact by having the interaction take the energy and move it perpendicular. So that would be the story. The elements of the story. Force bits hitting like light. Force bits are parts that make up light. Light is an interpretation of the force bits at a specific frequency by the receiving medium's surface. Right, so light is just taking what would be the normal chaos of arrows being at very irregular distances, and saying that if I put them at regular distances, if I separate them by a precise distance, they can in fact affect electrons in specific ways. So if I send them in this specific pattern, then I will I'll be able to move electrons in such a way inside a material where all the electrons are moving the same amount of distance. And by moving the same amount of distance in a substance, the electrons essentially just create a wave in the substance, and that wave moves the surface. So this surface got hit, and essentially it's going to make this surface move out. And by this surface moving out, it's going to create a pattern in the random stuff that's hitting that surface. So a bunch of random stuff's coming in here, and by moving the surface I create dead places between. Where the surface is moving away, the forces can't reflect, and when it's moving towards, they're more likely to reflect. So I'm going to create a pattern in the chaos where there's going to be places where there's no energy got reflected, so nothing's going that way, right? So I'm going to create a reflection, so nothing is going that way. Then I'm going to create a place where there's a lot of stuff going this way because I move the surface out. And then I'm going to create another space where there's nothing because I move the surface back with the energy. So nothing can reflect again, so I end up with a dead space, and then I have the capacity to reflect again, and so because I'm moving it out, and so when I move it out I want to reflect stuff. So as I move the electron out, I'm more likely to cause a reflection. When I'm moving it in, I'm less likely to create a reflection, and that's what's creating the dead spaces. So the dead spaces are kind of more important than the active spaces, you could argue. The important thing is that you have force and you have no force, and you have force and you have no force. So the dead spaces are more critical to the creation of the photon in some respects. I mean, obviously without the force you can't you can't affect some other thing you're going to affect, but the dead spaces is what makes there more force here. I mean, the fact that you don't have force here means you put the force in here, right? The same amount of stuff is going this way, and all you're basically saying is pile more of it in here, so there's more here, and there's less here, and then there's more here, and then there's less, and then there's more. So that's how you're creating the pattern. You're just taking the stuff that would have reflected here and moving it here instead. And so you're making it thick with force here, and thin, and then thick. Okay, well, that's saying the same thing over and over, but I mean, that's the principle. All right. Force bits are okay. Frequency by receiving. Light is an interpretation of the force at a specific frequency by the receiving medium surface. So yes, it's really just about the surface, and if you're going to transmit the light, what you have to do is have a surface that essentially keeps that motion of electrons, motion, as the electrons jerking their way through the surface to get to the other side and jerk the external surface. All right. Kind of, and every square is a rectangle. Not every rectangle is a square. Yeah, I don't know about that. Gravity, on the other hand, uses every kind of rectangle to generate momentum in a direction. All right, well, I don't know what that analogy is. So all gravity is a little, it's fundamentally outside the realm. See, this is all about charge, the attraction force and the repulsion force. It's about creating these two different kinds of interactions. Gravity doesn't care. Gravity is just recognizing the fact that you had an interaction, okay, that you took force going in a direction and you had to consume it, okay, and by consuming it, by moving an electron, the force isn't getting where it was going. So if any motion is absorbing force, that is, as this thing moves, it's obviously moving away from this force, right? So the force doesn't hit it as quickly as it would have, all right? So it's taking it longer. But if it's adding velocity to this object, if it's making it move, then it's essentially being trapped, right? So it's in the trap now. And in exchange, something going some other way. And so a force doesn't get to an object, and that means the object has less pressure because the force got used to move something material that moves much slower. And then obviously the force, you won't know how much force it absorbed until it actually shows up, and when it shows up you have this terrible hard explosion because all the force that it absorbed. So you can't, gravity is dipoles, electrons and protons, But the catch is all of them are in different orientations. They're, they're this way, they're this way, they're this way, they're this way. They're mixed. So it's not really a charge thing anymore. It's just a motion thing. It's probably a better way to say that, but that'll do for now. Alright, hit by something we see as a photon. A surface, kind of every square uses every kind of rectangles. Yeah, well, anyway. They're just not getting hit by something we see as a photon. Obviously, the electrons can be moved by anything. Every arrow moves an electron. The point is that sometimes you can have arrows that are in sequence with each other, and that will move them in a more regular way. Send it at a frequency to hit it at a frequency. Yes. True if you isolate the source, the ray or the receiver, but isn't it technically only dependent on the receiver? I don't know what that means. Pattern is pattern. So if it leaves with a pattern, it's going to arrive as a pattern. Can other sources distort frequencies from different angles? Other sources distort frequencies. Obviously, energy can hit stuff as it's traveling and be distorted in the sense that its progress can be slowed down a little bit. That means its phase becomes broken. Or you can break something else, like you can scatter it and change its direction, and then it's not part of a sequence moving. The pattern isn't moving in this way then anymore. It moves this way, and it moves that way, and it's broken into little pieces. But isn't it technically only dependent on, can another source distort frequencies from different angles? So I don't know exactly what you're saying. Clearly, the movement of an object is one thing, right? So if I move an object and then I have on the surface of the object its motion, right? It's vibrating in and out, right? So there's more than one velocity that can be involved, and depending on which way you're going. So obviously if I'm moving away, okay, then I'm again running from the force, right? So the very thing I'm trying to send a pattern out into, I'm moving away from, which means that the length of the dead spaces will be longer, right? So, and then if I'm coming towards, it's going to be exactly the opposite. I'm going to compress the amount of dead space, and therefore the clumps are going to be closer. True if you isolate the source, the ray, or the receiver, but isn't it technically dependent on the, can other sources, or I don't know exactly what you were saying there. Okay, you kind of mentioned this, that time codes are all pretty and stuff, but I'm really not going to rewatch the video. Okay, you kind of mentioned this at 1306, to which I want to add, number one, this is where the ocean of crisscrossing rays becomes an even finer, more detailed argument. Reflecting photons imperfectly, the path of the rays crossing. The crossing doesn't matter to photons. Subtract and recombine to the initial frequencies respectively. Imaging this in 3D space is absolutely wild. Well, you can do with it all you want, but no, the photons don't interact with each other. See, they don't have two rules. So the theory would be is that blues never can even see whites. Okay, that all the vectors in the universe that the blues are traveling, no white bit ever travels that vector, so it can never hit it. So the whites are in a different plane of the universe, if you want to think of it that way. They're on different layers. One layer is just below the other layer. So the blues and the whites can never hit each other. They're on a different layer, if you want to think of it that way. If you can imagine it that way. And then if the whites hit the whites and the blues hit the blues, like I've pointed out before, if I have a perfect kinetic reactions, all I'm going to get when a blue hits a blue is I'm going to get something leaves this way and something leaves this way. Well, that's exactly what happens if they miss each other, right? I mean, if they miss each other, okay, that's exactly what it looks like. So the universe can't change. So the rays can't interact with each other. They can't do anything. But even if they do hit each other, all they can do is make perfect exchanges. I mean, if I hit a, if this thing is moving this way and this thing is moving, this way, all right, and I collide those two, well, all that's going to happen is this is going to go this way and this one is going to go this way. So I'm going to end up with exactly the same universe. So it just couldn't matter. So there's no point in thinking about the rays interacting with the rays. They only interact with the electrons. The electrons and the protons are the conduit that allow the rays to reflect and do these different things that make the universe different. All right. Let's see. Can other sources distort? Okay, I did that. This is where, okay, I read that. Absolutely wild. Well, whatever. I'm not looking for wildness. One could assume that these kinds of influences would constantly shift the colors of things. So again, I don't see any of that in the evidence, and I don't see any reason to play with it. Maybe even on the scale of our eyes can perceive, but you'd underestimate how overwhelming many of these regular interactions are taking place, how dense the ocean of recombined photons is. So again, the density of photons is very small compared to the density of bits that aren't part of a photon. There's more bits flying through space that aren't part of a photon than that are part of a photon. Okay, which mostly keeps a steady image of our surroundings. Also, there's a significant allowed error margin in the perception of color sameness. All these densities you pretty much addressed at around 23 blah blah blah, calling them here, here, here. Well, I guess the point I'll make is that you can understand that even if I make a random field, I'll create random pattern. So even in a random field, once in a while I'm going to create arrows that are at the same distance, okay? Just by accident. And I'd say that's the cosmic background radiation. And that the likelihood is that I'm going to be able to create more of that pattern in low frequency signal than in high. The higher the frequency, the more unlikely it is, because the distance thing. There's more arrows at more distance from each other than there are arrows that are close together, right? So I mean, theoretically, in a random field, there's more relationships to arrows that are further away from you than there is relationship to arrows that are close to you. So if you were to make a pattern, you'd have more likelihood of making a pattern in the lower frequencies than in the higher frequencies. One could assume that these kind of influences really shift colors of things. All right, maybe even the scale you could perceive. Yeah, so we did all that. Okay. The mentioned vibrations are the result. So again, I guess I just want to make clear that part of the argument is that photons are constantly being made and remade, and so the photon you see coming through a piece of glass isn't the photon that hit the surface, so to speak. This is the energy. The little clump of energy that hits the surface, we're saying it kind of dents it, and then it portrays that dent on the other side. So an electron moves here, an electron moves here to this new position, and what's going to happen is the photon is going to bounce off of that new position. The energy from the external universe is going to bounce off of that, and that piece of energy is going to become the new photon. So this piece of energy, I should draw it as just this or something. When it dented, when it moved this electron, it just moved this electron, and by moving this electron, it's causing the pressure that's already in the field to reflect from a different point, and that's the new photon. So no photon travels through the surface to the other side, because no quanta make it to the other side. The electrons make it to the other side. This electron pushes on this electron, pushes on this electron, and it just pushes the electron out. And by pushing the electron out, I create an irregular surface where this bit reflects way off here, but this bit reflected here early, and that's making the photon. Covering the force hitting matter perfectly symmetrically at the same time, but still in a manner that generally keeps them in the same place. You mentioned vibrations are usually... You measure the vibrations are the result of the converging force rays not hitting the matter perfectly symmetrically at the same time. But still in a manner that generally keeps them in the same place. Now, what I mentioned was the tipping point argument. The electron is held to a proton by an attractive force, and it's repelled by other electrons. So these electrons are repelling each other, and this is attracting. Well, obviously there's electrons down here that are repelling. And so there's a balance between this attraction and this repulsion to the other electrons. And what you're really trying to do here is you're saying how hard do I have to hit this electron, okay, to release it from this condition. So the argument would be is that you can move it, and if I move it, I'm going to move all these other electrons. But if I hit it a second time, then I bounce it out, okay, and then I cause the transmission of light, or I cause a reflection, or I cause some other effect. So it's one thing just to move the force through the pattern. It's another thing to create electricity or some other phenomenon. So if I want to create electricity, I have to hit it at a specific frequency. If I just want to transmit it, I don't have to worry about the frequency as much. Now, obviously, all substances are frequency dependent. Like glass is transparent to regular light, but it's not too transparent to ultraviolet. So if I have ultraviolet light, it doesn't do very well getting through the glass. Because the higher the frequency, it's disrupting the electrons and essentially causing scatter. So the blue photons get scattered, and so the energy doesn't get through because it moved the electrons too much. It hit them twice and caused disruption in the atoms, and therefore disrupted the ability for the pattern to be moved in one direction. If you move the pattern in a bunch of directions, you lose the pattern. Alright. The mentioned vibrations are the result of converging force rays not hitting the matter perfectly symmetrically at the same time, but still in a manner that generally keeps them in the same place. Well, I'm not sure about anything being in the same place. My example guesstimates. Photons hitting surface area. 1 million by 1 million pixels. Volumes, force bits, 1 by 1 pixels. Electron, 1,000 pixels. Or I guess that's, I don't know. I can't see if it's a comma. It looks like a period. Anyway, atom, 100,000 pixels. Well, we already sort of know some of that, but I'm just saying I would say that the electron has to be, like I said, just going by the reflection argument, going 12 atoms deep kind of argument. You're just saying how big does an electron have to be? It has to be at least 10% of the circumference of the atom. Or the electrons, right? You have more than one, so each electron could be 2%, and there's 5 electrons, that kind of thing. Anyway, 10 bullets at the same time and big sheets. I think misconceptions like this are the result of only partially considering the ocean of crisscrossing rays. It happens to me a lot. Well, again, the fact that they crisscross is irrelevant. The only thing that matters is they go in a dead straight line until they hit something, and that's it. They hit electrons and protons, and that's the only thing that changes anything. Is without the electrons and protons, the universe doesn't do anything. I still have to incorporate overlays of blue force interactions and red force interactions. Well, thanks for working on this. Maybe I'll do a video on some of the specifics I've learned, okay, about the left and right turns, because that's the trickiest part. the interaction where it changes dimensionally is the tricky one to figure out the rule for that. The math doesn't work when things are really close together or when they are really far apart. So I'm saying Maxwell's equations have those, they're strict rules. I mean, it's not just for Maxwell. Ampere's law, Gauss's law, they all have restrictions to when the law applies and when the law doesn't apply. And none of the laws apply, I don't think, when you get really close. Okay, atom to atom, they don't apply. Okay, nice. I feel like I need to hear that, but didn't know why yet. Yet why? And you make the photon out of two different photons. So, okay, so you're just recombining two broken ones is the point. It's not really making it out of two different photons. You're taking pieces of a photon and another piece of a photon that had the same phase and reconstructing the photon. Given the constant speed of force and the absoluteness of the frequency tempering obstruction of matter, these photons would have to come to one another from different angles, right? Just checking. Well, obviously the different angles is where you have the opportunity to recombine the phase. So when you're changing the phase, you have to rely on diffraction somewhere. You have to create some sort of longer path. Because if they take the same path, and you're just not going to get anywhere because you're not going to recombine the phase. So I'm basically arguing, look, you have two photons, they get broken in some way. So I'm just going to draw it like this and say, okay, this is the real photon, this pattern. So it's missing an element because this element got pushed here because it's out of phase. So this one went through with a filter, got slowed down twice as much as the other ones did, so it's in the wrong place. And then you have another photon over here, okay, that has that piece, right? And has that piece, but it's missing this piece. Okay, so these two photons as they are now couldn't be seen. But if these two photons can be directed to hit the same location, okay, then you can take this photon, right, and you could move it, you could phase shift this one this way, and you'd still end up having this bit match this hole, and that's all you really want to do. You want to fill the places where there's a void. So I could have it, they could match going straight, and they could match at one wavelength of change. If I make it so this distance is one wavelength more distance, and I could still make these two things hit a surface and be seen as a photon. So because this hole, okay, was in this position, it means that either this one can go here or it can go here. So I can either have this photon slow down, which makes this one here, or I can slow this one down, which makes this one here. So I can make the photon either way using this one. So I could say this is the parts car, right? I'm using this one for parts. Okay, and this is my real car, right? I want to make a car out of this. This car is almost running. It's just missing this one bit, right? So all I'm doing is saying I'll take parts from some other photon. So these two photons are going to hit the surface at the same time based on this angle. So they can hit the same time straight lines and it'll work. If they hit the same time from one of them's coming from this angle, that'll still work and it'll still be a photon. Right? And I can even change it to have this angle from this one. So instead of straight, it came from over here. And that'll work. So I have a few choices that will make the photon look like a photon. I'll get my frequency back. But that's all you're doing. You're reconstructing frequency. And you're doing it out of photons that were either, like in polarizing film, the photons just have their elements moved, right? So their phases are off. They have bits where they shouldn't be. All right. Or in the case of the slits, you've actually killed some of them. Well, and yeah, you've killed some of them, and okay, you've diverged them, that which has sent them on different paths. So not only have you broken them by breaking off pieces, like just destroying a piece, like there's just no piece there anymore. You've also sent each one of these pieces in a different direction. So now you're really got a bunch of, you really have to have quite a volume of light to be able to reconstruct any photons at all. So the very idea of creating a single photon that goes through the slits and does anything is kind of a bogus idea. That's why the pattern is always much fainter and uglier with single photons, because the very concept of a single photon is bogus. You really have to have a certain volume of light go through here to be able to take these pieces and have pieces flying all over the place. If you only put 3 photons in, you'd have pieces going everywhere, and you'd have no chance of making a photon, but you wouldn't have enough pieces. So, in theory, that can't work. It's, there's no single photon gun. There's no concept of even the single photon. It's a silly idea. All right, anyway. Let's see. And you make a photon out of 2 different photons. Okay, right. Given the constant speed. Right. So we already did that. All right. Gary suggests an additional test for the slit experiment. An even temperature throughout the projected surface, a dead spot and a light spots alike would point towards Gary's theory being correct. Right. I'm arguing that the quanta is not destroyed in the slit experiments, the substance of it, right? Most of the quanta gets through, and that even the dead spots are getting hit by plenty of little bits. So when you have that pattern of light and dark, these are reconstructed parts, okay? So they're cars, but you're still hitting this with a ton of parts. And the parts represent quanta, it represents gravity, it represents real energy. It's not energy, it's energy. And it's pressure. And it will do what pressure does, which is create heat. So that you should really technically have just as much heat here as you have where it's on. And I think the polarizing films kind of bear this out in the sense that we know that they don't get hot and blah, 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 blah. Because they're not destroying photons. Photons are going through the polarizing film. They're just not in a form we can see because their frequencies are broken. But the little bits are still there. They're just piled up in the wrong order. So the same number of bits is hitting here, the same number of pieces. It just happens that the angles are right, that you can reconstruct a photon here, but you can't reconstruct it here. So I would argue that if you do this with white light and you see the red pattern is here, and the blue pattern is here, this is blue, and this one's red. There's really blue photons also going over here. Just the angles are wrong to put blue photons back together again. So pieces of blue are going here, but you don't have the right angles to put a blue photon together there. So you can only see the blue ones here because that's only where the wavelength difference, the difference in length of the path has to be the wavelength of the light. So you only make blue ones here. But blue ones are going here, and blue ones are going here where the red one is. You're just not going to reconstruct a blue there. All right, Gary's theory being correct, as opposed to the temperature correlating to the light-dark pattern. Right, I'm really excited to hear about you wanting to do this experiment. This could be the potentially viral 60-second video we need to pierce the armor. Yes, could be. Yeah, okay. I mean, it's curious that it's never been done as far as I know. I mean, it's not that, it seems like somebody should have thought of it to see if there's, if temperature, just to see, yeah, because, yeah, it tells you a lot. Do you have access to significantly isolated testing environment? Well, that's the trick is photons are really weak, in terms of the amount of energy they provide. So, but with lasers and everything else, it seems like it should be really doable. How much money do you need to fund it? Oh, these are interesting questions. I have to first figure out whether, like I said, I kind of was thinking thermocouples are very small. You can make them very small enough for the experiment. It's just that, what's 1,000 of them going to cost? Then you also have to tie them into some electronic device that can keep track of all those different sensors. When the magma inside the Earth is swirling, it consumes force in both directions. Yes. Semantic nitpick because it sounds vaguely non-conservational. It delays and dilutes force, right? Well, it delays force in both directions because the argument is all motion is a constant. It really is constantly consuming energy to move. It doesn't have perpetual motion. The electrons and the protons don't have perpetual motion, so they have to constantly be pushed. So the argument sort of is that when their magma moves this way or the magna moves this way, it's consuming energy in both of those directions at the time it's moving in those directions. Okay, so the energy doesn't get where it was going. So the external pressure is being consumed moving the matter in the magma, and it's doing it in both directions. And the catch is that if I'm somebody over here, I can see something absorb the energy that was going to hit me. I can't see it absorb the energy that wasn't going to hit me. So this is irrelevant to me. This is really relevant to me. So it makes me move in because all I see is the absence of force getting to me. I don't see the absence of force getting to this guy over here. So it's like I don't see the Chinaman absorbing energy to move towards me, to be accelerated into the earth. But technically, in a way, the fact is he's the one that's causing the deficit that makes me move into the earth, right? And I'm doing the same to him, theoretically. So I'm just saying, obviously that time scale would be, a little bit out of whack just because of the speed it would take for me to feel the Chinaman. But in a sense, I'm really feeling him. Some portion of the gravity, I'm falling into, the absence of force hitting me from the bottom of the earth, is a byproduct of the fact that he's there to absorb it. All right, so that's probably enough for this round, right? Yeah. I'll just arbitrarily see how much more of this. Oh, there wasn't that much more, so maybe I can finish. All right, when the magma inside the earth is swirling, consumes force. Okay. In a roundabout way, it consumes big-scale motion. Conventional physics sometimes has a different ranking of basicness and effects from you, but yours would be force smaller than motion, smaller than temperature, smaller than electron protons. Obviously the force is smaller than the electrons and the protons. Smaller, okay, sound, photons, electricity. I don't know what that means, but yeah, I don't know how you're ranking things. Obviously it's force, electrons, protons, then you could say atoms, then you could say compounds. You can get bigger and bigger. But the force that causes charge, electricity, electricity is just the motion of atoms through a conductor, right? You could argue. It's the change in the shape of them, so it's the motion of the electrons. It's changing the location of electrons and protons. You could argue that, and that's what's being transmitted is a change in the shape of the atoms, I would argue. So it's not really a force. It's the force that changed the shape. But it has to go through. It has to go through that process. The force has to be interpreted by the atoms before you have electricity. Electricity is completely dependent on the existence of atoms. Without atoms, you don't have electricity. All you have is charge. Well, kind of clumsy. Actually, I had this in my head for months, so I'm just throwing it out there to be improved upon. Okay, that's it. Thanks again for tending to the God removal from physics so consistently. Thanks again for tending to the God removal. Okay, yes. Somebody needs to do it. It's true. So yeah, I think it's constructive people misunderstand, fairly easily. So that's the trick here. See, and I'm always with it. It's been with me for 10 years. So all of this is so. What do you mean? I have to explain it? It's all kind of obvious to me, and so I don't realize sometimes that I can be saying something that's not really grokked. are understood. So anyway, okay, until the next time and such.